Hi guys, today we will be discussing about diffraction and properties of waves. We have discussed about reflection and refraction in our previous videos. The links to those videos are given in the description below. So guys, what is diffraction? The spreading of wavefronts when they travel or pass through a gap or an edge is known as diffraction.
Now let us discuss more about diffraction. The spreading of wavefronts when they travel or pass through a gap or an edge is called diffraction. So what does this mean? When plane wavefronts pass through a gap or an edge, they become circular wavefronts. If the size of the gap is in the same order of the wavelength, the diffraction patterns are more prominent. So what does this mean? The gap is too large compared to the wavelength, the diffraction patterns are not that prominent. We'll discuss more about this in the coming videos. Here you can observe that if the distance in between the wavefronts and the gap is quite the same, then the diffraction pattern is more prominent. And when the gap is quite large compared to the wavefronts, you can observe that the diffraction pattern is less prominent. Sound can be diffracted as it passes through window slits or wall corners. As you can see, the cleaner is standing at a point where he cannot see the radio, but he can hear the sound from it. This is due to the diffraction of sound waves by the wall corner.
Let us look at the following demonstration done using the ripple tank to get a better understanding about diffraction.
Here we observe the diffraction of water waves. The setup here is the ripple tank arrangement. The electric vibrator connects the tip of the needle. Circular wavefronts are produced by the tip once it hits on the water surface. These wavefronts travel in the direction along T. Let X and Y be two vertical glass plates immersed in the tank far away from the vibrating source, having a gap in between them. The wavefronts are then incident on the gap AB, where AB acts as an obstacle, and this is also termed as an aperture. If you just think, you would imagine that only some of the light is being passed through the aperture, but in this situation it is quite different. The wavefronts which pass through the AB aperture will result in a number of wavefronts which are circular in nature and will spread out in all directions. The waves emerging from the aperture AB would deviate from the original path P and would travel in directions such as Q and R shown here. This deviation from the original direction of light and formation of a new circular wavefront is due to the bending of waves. So this phenomenon is known as diffraction. Let us once again look at the definition of diffraction. So what is diffraction of a wave? The bending of a wave or deviation from the original direction of the light wave is known as diffraction of a wave. Let us discuss about diffraction of light waves here. The wavelength of water waves and light waves are quite similar compared to that of sound waves. Thereby, diffraction requires a small size obstacle for observation during this experimentation. Let us look further into the definition of diffraction. The bending of light waves around an obstacle whose dimensions are comparable to the wavelength of light which is incident, hence spread into a shadow, is called diffraction. Now let us observe what happens when a straight edge is placed. Here we have a ripple tank once again, but instead of the aperture, here we have a small obstacle. Let's think of a foot ruler. The length is in contact with the water surface and the width is perpendicular to the surface. This type of surface is called a straight edge. The tip of the needle vibrates here and is moving in the following manner. It is in fact the source. The wavefronts are produced and they move towards the BD straight edge, and the waves spread out in all directions. The bending of waves takes place here, similar to what we discussed in the aperture situation. Diffraction is observed in the straight edge in the following manner.
So guys, what are the applications of diffraction?
A CD reflecting rainbow colors and even the hologram projection is an application of diffraction. The reddish appearance of the sun during sunset or sunrise is also due to diffraction. We can also see this phenomenon from the shadow of an object. The spectrometer used in spectroscopy is spectrum observed through a glass prism by a spectrometer, and even the X-ray diffraction used to identify the crystal structures are applications of diffraction.
So guys, that is about diffraction of waves. Let us discuss about interference of waves in our next video. Hope you guys enjoyed today's video. Have a nice day.